Activity 5, electric motors and generators. There's a lot going on here, people. This is a lengthy activity, it seems like. And so to help you make sense of it and get organized, here's what it comes down to. So we got two parts, basically. Part one is about how you can generate magnetism from electricity. Part two is about how you could generate electricity from magnetism. So the whole overarching concept really is the coexistence of electricity and magnetism. In high school, definitely in college, there are like physics courses that you take that are literally called electricity and magnetism, like bundled together as one class, because if you have one, you have the other, and vice versa in general. So in this activity, I'm explaining that to you, exposing that to you, the coexistence of electricity and magnetism. And then also at the same time, because this is what we'll be getting into next, at the same time using that to explain how electric motors and generators work, because those things function on that coexistence of electricity and magnetism. Yeah, that's coming up next. You'll see. So part one, when you have electricity, you have magnetism. So to show you that is true, we use this whole compass core solenoid thing to show you evidence of that phenomenon. So if it's true that when you have electrons flowing through a wire, a magnetic field is generated, which is an electromagnet, how an electromagnet works. If that's true, then we could expect this to happen. Then we can expect, if we, okay, first of all, a compass needle moves in response to, moves in response to magnetic field points, normally due to the magnetic field of the Earth. But we can override that. We could force it in another direction with a stronger magnetic field than that of the Earth. So if this is true, then if like a solenoid, if we pass current through the solenoid, through this wire, this cold wire, and it does in fact generate a magnetic field. If that's true, then as soon as we start passing current through the solenoid, it should move the needle. And it does. And that's what I showed you in the YouTubes. In fact, I also showed you that if you bring your phone in close to the compass needle moves. So this must have a magnetic field as well. And it does. All right, in the first trial, when I first spin the hand generator and send current, electrons flowing through the solenoid, through the wire, a magnetic field is generated through or from the solenoid, which then magnetically forces the compass needle to move, in another direction, other than where it normally points from the Earth's magnetic field. The first trial, whenever I first did that, the compass needle pointed from west to east. The red end of the needle is kind of like the tip of the arrow, and it's pointing to the east. I mentioned this to another student a few times in different ways, that if you imagine the compass needle as an actual arrow that you'd shoot from a bow, like Arthur shoots from his bow in RDR2. Gamers, you might know what I'm talking about. Yeah, if you had the arrow pointing to the east and you shot that arrow, the arrow would travel essentially from the west to the east, in a sense. Okay, so the compass needle rotates, zoop, and points in this direction to the east. That must mean then, A, there is a magnetic field generated by the solenoid, and B, that magnetic field, at least at that point, okay, in that location, through the core of the solenoid, through that little tube that is the core of the solenoid, the magnetic field at that location is pointing in that direction. So if you grab one of these dotted blue arrows that are a little bit longer because they're supposed to represent the direction of the magnetic field, you grab this one, okay, and put it kind of like that. Okay, so the concept here is to help you see that wherever the direction of the magnetic field is at any location, if you put a compass there, the needle will point in the direction of that magnetic field. Okay, and vice versa, right? If a compass needle is pointing in a specific direction, that must mean that there is a magnetic field pointing in that direction, okay, at that location. In the next trial, I reversed the direction of the current by spinning the generator handle the other way. Here the needle flipped and pointed the other direction. So if before in the first trial it was pointing west-east, well now it's pointing east to west, like this, right? Yeah. Okay, if the compass needle is pointing in that direction now, that must mean that the magnetic field generated by the solenoid at that location is pointing in that direction, is now flipped. All right, so look at that. Compare those two. Okay, current in one direction, current flipped, current in another direction. So if you reverse the direction of the current, you reverse the direction of the magnetic field. That's a little kind of like side discovery. And that connects to here in the intro, the polarity of in other words, the direction of the magnetic field of the solenoid, the polarity of it depends on the side that the current enters and the side that the current leaves. In other words, the direction of the current flow. If I reverse the direction of the current flow, had current coming in this way and exiting that way, it would flip the polarity. This would become the South Pole. This becomes the North Pole. Details, general concept I want you to know, at least, is if you reverse the direction of the current, you flip the magnetic field, you reverse the magnetic field. In the next trial, I weakened the current, so I spun the handle much slower. Here's another connection I want you to make: is the strength of the current has an effect, a direct effect on the strength of the magnetic field. Okay, so we have two variables that affect the magnetic field in some way: the direction of current and the strength or speed of the current. Okay, the direction of the current has an effect on the direction of the magnetic field. The strength of the current has an effect on the strength of the field. In this trial, whenever I had the current flowing in the opposite direction, the magnetic field was pointing to the west. So it goes from normally pointing north to west. If I weaken the current, the magnetic field is weaker, so it's kind of like a half effort. So it's not strong enough to actually get the needle wholly rotated. It's like it's pulling on it to draw it to the west, but not with strong enough force. It's like the force is just too weak, so it's not like pulling it the whole way to point to the west, so it's pointing northwest. Something like that. Yes, it looks awesome. The direction of the magnetic field is kind of awkward and pointing in that direction. The important point is, again, for you to just draw that connection between strength of current and strength of field. The weaker the current, the weaker the field. The stronger the current, the stronger the field. Likewise, the direction of the current has an effect on the direction of the field. Zebba debba debba. Okay, generators. What do people use generators for? Oh my gosh, if your power goes out, you don't have electricity, so you use a generator to get electricity. For some people, like myself, my wife, we love the natures, and so some people have camps and RVs and stuff, and they use generators out in the natures, and because there's no electricity out there. Some camps have it, but whatever. Use it for electricity. What does your hand generator provide? Electricity. Okay, so generators their output is electricity. What's the input? With a hand generator, if I'm getting electricity out, this goes back to, what was that, Unit 3, Activity 3? If I'm getting electricity out, electrical energy out, I got to put some energy in. What form does that energy come in? It comes in the form of motion. Okay, so generators convert motion into electricity. Before, I was just telling you guys that in the generators, actually the silver cylinder in there, some kind of mysterious action takes place in there for that conversion of motion to electricity to happen. What's going on in there? Well, I guess that's what part 2 is for. I'll cover the rest in part 2. All right. All right.